Okay, you're given the formula for the derivative of a function f. That's the derivative right there. And we want to find out the critical numbers or the stationary points for the original function, which means when does the first derivative equal 0? Now we could just set this equal to 0 and solve it that way, but they're suggesting letting u equal x to the 1/2 so it's easier to see how to solve the resulting equation. So if we let u equal x to the 1/2, that later on is going to imply that x equals u squared. And here's what we get after the substitution. And we make note of the fact that when we solve that equation, u cannot equal 0. Multiply every term by u to clear the equation of fractions. Write it in descending order. You can use split the middle, factoring by grouping, or just factor by trial and error to find out how this factors. I split the middle, minus 10u into minus 9u to plus a negative u. Used factoring by grouping, and there's the factoring. That means u equals 1/3 or u equals 3. If u equals 1/3, that's because x equals u squared. That means x equals 1/9. If u equals 3, then x equals 9. Now in part 2, you're supposed to prove that these x values generate a max and a min respectively. Here's the graph of the original function, which we find in part 3. And there is a relative minimum that looks like at 9 and a relative maximum at x equals 1/9. Now, how do you show that? Well, they ask you to find the second derivative. Here's the first derivative given. Second derivative, use the power rule, reduce the exponent by 1. And we want to know we're going to plug those stationary points or those critical numbers into f double prime. And the sign that results will tell us whether we have a max or a min. So if I put 1/9 into the first derivative and simplify, I get this, which is actually negative 36. All I care about is that that's less than 0. And when it's less than 0, that tells you that the original function is concave downward. When I think less than 0, I think negative, and I jot down a frown, and so the critical number 1/9 generates a maximum. And f double prime of 9 actually reduces to 4/9 if you go through the arithmetic, which tells you positive smiley face, so 9 generates a minimum, which is what we got back here on board 2. Okay. To find the actual original function, we want to find the antiderivative of f prime. So we follow the rule, raise the exponent by 1, multiply by the reciprocal of the new exponent. Of course, it's an integral, constant of integration there. So there is a general antiderivative, but we're told that the original function passes through 4, -7. That means when x is 4, right here, we generate a y value of -7. So solve this equation for c, and you get, in the end, c equals 5. So there is the original function. And that is what this red graph is the graph of, that original function right here. Okay, there you go. Hope that helped. If you have any questions, post a comment.